Alrighty, so thank you for tuning in to part 2 of these video notes. That way we can go through a couple examples together. All right, notice that this graph, this quadratic looks very different than the one from the previous video. All right, first off, it's upside down. It's opening down this time. All right, so that's totally okay. Your quadratic, your parabola sometimes opens up and looks like that U shape. All right, sometimes opens up and looks like this, and sometimes it can be flipped and opened down. We'll explore why as we continue on in this unit, but for right now, we're just trying to identify those key aspects, all right, those key features of these parabolas. So we've got this function g of this quadratic. We want to identify these parts. First off, what's the vertex? Well, the vertex is either your highest point or your lowest point. So if you notice, your vertex is right here, at this point here. So your vertex is at -1, 2. Those are the coordinates of your vertex. Next up, we've got a y-intercept, also known as your vertical intercept there. All right, that's where it crosses the y-axis. So I'm going to label that point here, happens to be the origin. Okay, so remember your y-intercept is also known as your vertical intercept. And then for the next one, the x-intercept's also known as your horizontal intercept. Here we have two. We have two x-intercepts. Right here is one of them, and then the y-intercept actually is shared. So we have an x-intercept at the origin, 0, 0, and also at -2, 0. Okay. Does the graph have a maximum or a minimum? How do you know? Well, that goes back to number 1 with the vertex, because the vertex is going to be your max or your min. In this case, we have a maximum. How do I know? Because the graph opens down. So the graph opens down there. Okay. Where is g increasing and where is g decreasing? Well, this is going to be a little different because that parabola is opening down. So it's actually increasing first. It's going up, like if I get a highlighter here, it's increasing first until it reaches that vertex. All right, so it's increasing when x is less than, what's the x value there? -1. So when x is negative, if x is less than -1, your graph is your graph is increasing. All right, where is it decreasing? Okay, notice that that's the rest of the graph here. After it reaches that vertex, it's going to start going down again. So where is it decreasing? When when x is bigger than -1. As the x values are getting bigger on this graph, we're going to get bigger negative numbers out. Okay. What is the axis of symmetry? Well, I'm going to draw that in. That is the line, the vertical line that cuts your parabola in half and goes through your vertex. Okay. It is the same as the x coordinate of your vertex here, because that's what it's got to go through. So the axis of symmetry is x equals -1. We drew that into the diagram. Notice how those like x-intercepts here, notice how those x-intercepts, like this is 1 to the left, so this is 1 to the right. Like you have that symmetry going on there. All right. And then lastly, describe the domain and range. So we talked about in the previous video how the domain is always going to be all real numbers. You can plug in anything you want into a quadratic because you're just squaring it. And there might be some other stuff that you got to do, but for the most part, you're just going to be squaring those numbers, and you can square any number. All right, so all real numbers. Now the range gets a little tricky because you got to pay attention to your vertex. All right, you can plug in any value you want, or sorry, for range. You can get out any value you want up until this maximum value of 2 for the y values. So we're going to say all real numbers less than or equal to, so I'm going to use that symbol, leave it here for what it's saying, less than or equal to, 2. 2 is the highest possible output we can get right here. We're never going to get out anything bigger than 2. Okay, so there's another example of identifying those key features. To close us out, we're just going to look at this example. Sketch what a graph could look like using the provided information. All right, so in number one, what it could look like. So we want to be very careful about what each of these features is telling me. It has a minimum. So think about, what does that tell you about the graph? Oh, if it's got a minimum, it's got to open up. All right, the axis of symmetry at x equals 3. So I'm going to draw in a vertical line here at 3, because that's going to be the axis of symmetry. That's what AOS stands for. This here stands for axis of symmetry. So that's cutting the parabola in half. And then it doesn't have any x-intercepts. So we know the graph opens up and it doesn't have any x-intercepts. So you got to think, hey, it doesn't tell you where the vertex is. So that's why it's saying what the graph could look like. But if it doesn't have any x-intercepts, I know the vertex has to be above the x-axis. So for example, I'm just going to put my vertex here, and then I'm going to draw my parabola. Okay? As long as it has no x-intercepts and it's checking off those boxes, you're in good shape for what the graph could look like. All right. Number 2 says it has a y-intercept at 0, 5. So I'm just going to check that off, and I'm going to plot that point right here at 0, 5. It has a maximum. All right. So if it has a maximum, then you know it's got to open down. And it has an axis of symmetry at x equals 0. So this axis of symmetry here, I'm going to draw that in with just a dashed line. Okay, so notice that that axis of symmetry goes through your vertex here. Your axis of symmetry goes through your y-intercept, which means that y-intercept has to be your vertex. So from here, I'm just going to sketch down. I'll make that hopefully a little bit more symmetric here. There we go. That's what your parabola could look like there. It's got a y-intercept at 0, 5. It has a maximum, and it has an axis of symmetry at x equals 0. Okay? Now, last one here. So we have x-intercepts at -2, 0 and at 4, 0. Okay? So we plotted those 2 points. It has a minimum, which means your graph needs to open up. All right? Now, we're going to be exploring these more in detail later, but remember this idea of symmetry. Your x-intercepts are going to be the same distance away from your axis of symmetry. So notice that this is 1, 2, 3, 4, 5, 6. There's 6 spaces in between your x-intercepts. So if I cut that in half, the axis of symmetry has to be 3 units away from both of those. So if I go 1, 2, 3, and I put my axis of symmetry here, notice how these are both 3 units away from that axis of symmetry. All right? So we've got that idea. It has a minimum, so I'm just going to put my vertex somewhere below the x-axis, or the x-intercepts, and then I'm just going to connect this and form the graph of my quadratic. All right? So that's an example of what it could look like, because it covers my bases on what the provided information was. All right, so I appreciate you watching, listening, and taking notes throughout this video. All right, this is an example of we're just introducing some key features to the graph of a quadratic, also known as a parabola. All right, so as you go back to today's essential question, what are the key features of the graph? All right, you can list out some of this new vocab like vertex, x-intercepts, y-intercept, axis of symmetry. Okay, so I'd encourage you to continue to look through these notes as you practice. Thanks so much. Have a good one all.